everyone, welcome back to our AS Level Further Mathematics Past Paper Walkthrough series. I'm Haiyan and I will be your video host for today's session. Today, Siddharth will walk you through this paper, Winter 2023 and Paper 11. So, are you ready? Let's get started.
The first question is, by considering r plus 1 square minus r square, use the method of differences to prove that the summation of 1 to n of r is equal to n into n plus 1 by 2. So let's just consider this. So first thing we can write is r plus 1 square is r plus 1 square minus r square is just r square plus 2r plus 1 minus r square, which is just 2r plus 1. So let's take the summation of both sides. So summation from r is equal to 1 to n of r plus 1 square minus r square. So this is going to be the same thing as summation of from r is equal to 1 to n of 2r plus 1. So let's consider this right side. So when r is equal to 1, it will just be 2 squared minus 1 squared plus, and when r is equal to 2, it will be 3 squared minus 2 squared. So plus 4 square minus 3 square all the way up to n plus 1 squared minus n squared. So what we notice is that all of these cancel out. So 2 squared minus 2 squared, this plus 3 squared and minus 3 squared, all the way on and on, until we are left with n plus 1 whole square minus 1 square, which is just 1. So this is the result of, I won't say this down, so just give me a second. Yeah, so this is what we get from the left-hand side. From the right-hand side, we can break this up as 2 summation of r from 1 to n of r plus summation from r is equal to 1 to n of just 1. So this is what we're trying to find out. So let's just call this x. So n plus 1 whole square minus 1 is equal to 2x plus the summation from 1 to n of just 1 is just going to be n. So nx plus 1. So this left-hand side we can write as n squared plus 2n plus 1 minus 1 is equal to 2x plus n. So shifting the n this side, it becomes n squared plus n is equal to 2x. So x is nothing but n squared plus n by 2, or n into n plus 1 by 2, which is what we have here. So that's the first question. Given that summation from r is equal to 1 to n of r plus a is n, find a in terms of n. So we can just break this up as summation from r is equal to 1 to n of r plus summation from r is equal to 1 to n of a. So we already found this out before as n into n plus 1 by 2 plus. So this will just be a n, and this is all equal to n. We have n squared plus n by 2 plus a n is equal to n. So divide everything by n. So n plus 1 by 2 plus a is equal to 1. So a is equal to 1 minus 1 plus n by 2, which is just 1 minus 1 by 2 minus n by 2, which is just 1 by 2 minus n by 2. Yeah. So let's move on to the next question. So prove by mathematical induction that for all positive integers n, 1 plus 2x plus 3x whole square plus dot 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 plus nx to the power n minus 1 is this thing on the right hand side. So the format for proof by mathematical induction is always the same. So we start by stating the base case. So for n is equal to 1, we just have on the left hand side just 1. And on the right hand side, we have 1 minus 2x to the power just 2x plus 1x square. So divided by 1 minus x whole square. So this top can be factored as 1 minus x whole square. So divided by 1 minus x whole square, we get just 1. So now we write the next statement, which is assume that for n is equal to k, we have 1 plus 2x plus 3x squared plus dot 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 kx to the power k minus 1 is equal to 1 minus k plus 1 x to the power k plus kx to the power k plus 1 divided by 1 minus x whole square. So basically what we did, just substitute k in the formula in place of n. So let's move to the next part, which is that we have to write the final case, which is for n is equal to k plus 1. So let's check for n is equal to k plus 1. Oh, by the way, over here we have to write since LHS is equal to RHS, statement is true for n is equal to 1. That. So let's check for n is equal to k plus 1. See, we've got on the left hand side 1 plus 2x plus 3x square all the way up to plus kx to the power k minus 1 plus k plus 1 times x to the power k. So k plus 1 minus 1 is just going to be k. So we've got on the right hand side. So okay, so before we do that, let's notice that this thing is what we had previously. It's just this. So we can substitute this here. So let's do that. So we've got 1 minus k plus 1 times x to the power k plus kx to the power k plus 1 divided by 1 minus x whole square, and plus k plus 1 times x to the power k by 1 minus x square times 1 minus x square. So this is just going to be 1 minus k plus 1 times x to the power k plus kx to the power k plus 1 plus k plus 1 x to the power k times, okay, let's expand this bracket while we're at it, 1 plus x square minus 2x divided by 1 minus x whole square. So I'll erase this top statement, but you should leave it in the exam. You should write it in the exam. I'm just erasing it because I don't have space. Let's do this. So let's expand the 1 minus. So that minus, let's expand this part basically. So 1 minus k times x to the power k minus x to the power k again plus kx to the power x plus 1 plus, and let's not expand this part, just multiply the 1. So we've got k plus 1 times x to the power k plus k plus 1 times x square minus 2x. Yeah. So this is all divided by 1 minus x whole square. So we got 1 minus kx to the power k minus x to the power k plus kx to the power k plus 1 plus kx to the power k plus x to the power k plus k plus 1 times x square minus 2x times x to the power k divided by, divided by 1 minus x whole square. So this minus x to the power k and plus x to the power k cancel, and this minus x to the power k and this plus x to the power k happen. Okay, so to make it more obvious what's coming, so let's actually directly substitute k plus 1 into this formula over here, and we can try to reverse work it out. So we've got, so if we substitute k plus 1, we're going to get 1 minus k plus 2 times x to the power k plus 1 plus k plus 1 times x to the power k plus 2 all divided by 1 minus x whole square. Okay, so let's try to rearrange it in such a way that we get that. So right now what we have is 1 plus k x to the power k plus 1 plus k plus 1 times x square minus 2x times x to the power k. So divided by 1 minus x whole square. So this part we can write as 1 plus k x to the power k plus 1 plus k plus 1 times x to the power k plus 2 minus 2x to the power k plus 1, right? Got the k plus 1, so let's leave this part as it is. So we can just try to match it. We can see that this and this part, this k plus 1 times x to the power k plus 2 are already matching. So let's only try to bring out this part. That's going to be 1 plus, I think so, there was some minus sign error, but it's fine. Okay, nothing. So kx to the power k plus 1 plus k plus 1 times x to the power k plus 2 minus k plus 1 times 2x to the power k plus 1. Okay, all divided by 1 minus x whole square. So I'm gonna have to erase again because it's quite a lengthy simplification. So I'm gonna continue simplifying directly. So we already matched this part, this k plus 1. So let's just try to fit this in such a way that it matches that. So we can write it as 1 plus k x to the power k plus 1 minus 2k plus 2 into x to the power k plus 1 plus k plus 1 times x to the power k plus 2, all divided by 1 minus x whole square. Okay, and what we get from this, when we have this x to the power k plus 1 and minus 2k to the power 2k plus 2 times x to the power k plus 1, just factor out the x to the power k plus 1. We have x minus 2k plus 2 into x to the power k plus 1, right? So it just becomes k minus 2k plus 2 just becomes minus k plus 2, right? So this becomes sorry, minus 2k minus 2, so it becomes minus x minus k minus 2. So that's what we want. So we have minus 1 minus k minus 2 times x to the power k plus 1 plus k plus 1 times x to the power k plus 2 divided by 1 minus x whole square. So we've proved that so this thing which we just got is what we would have gotten if we directly substituted x is equal to k plus 1 in the formula directly. So the formula is true for n is equal to k plus 1 as well. Since formula holds, and this is the final statement, so since formula holds true for n is equal to 1, k and k plus 1, by the principle of mathematical induction, it is true for all positive integers n. So you have to write this final statement. So let's move on. So we moved on to the next question. So it's the quadratic equation x to the power 4 plus bx cubed plus cx square plus dx minus 2 is equal to 0 has roots alpha, beta, gamma, delta. So they've given all these facts and they're asking us to find out the values of b, c, and d. So let's do that. So they give that alpha, beta plus gamma plus delta is equal to 3. So that's just the sum of roots, which we know is minus b by a. So they've given that it's equal to 3. And since a is nothing but 1 in this equation, minus b is equal to 3. So b is equal to minus 3. Just give me a second. So the next thing is the sum of roots, sum of the squares of the roots. So this is nothing but sum of the roots whole square minus 2 times the sum of roots taken 2 at a time. So this we they already gave as 3. So this is going to be 3 squared minus 2 into sum of roots taken 2 at a time is going to be c by a. Okay, and a is just 1. So this is going to be equal to 5. So 9 minus 2c is equal to 5. So we've got 2c is equal to 4, c is equal to 2. And this one, so when you simplify it, we get, so taking the common denominator, we have alpha, beta, gamma, delta. So we have alpha, beta, gamma, delta. We have beta, gamma, delta plus alpha, gamma, delta plus alpha, beta, delta plus alpha, beta, gamma. So this is nothing but the sum of roots taken 3 at a time by the product of roots. So the sum of roots taken 3 at a time. So we know that the sum of roots single is minus b by a, double is c by a, triple c by a again, and the product of roots is just going to be, hold on one second. It's easy. It helps when you write it down like this. Oh yeah, so this is going to be minus d by a. This is going to be e by a. So the product of roots is e by a. So this a and a cancel out, and we just have minus d by e. So they actually gave e as minus 2, right? So minus d divided by minus 2 is going to be equal to 6. So d is just 12. So minus 3, 2, and 12. So let's just check that. So given also that alpha cube plus beta cube plus gamma cube plus delta cube is equal to minus 27, find the value of the sum of things taken to the power 4. So they give the equation as x to the power 4, and we already found out the values of b, c, d. So it's minus 3x cube plus 2x square uh, plus 12x minus 2 is equal to 0. Right? So the S4 minus 3S3 plus 2S2 plus 12S1 minus 8 is going to be equal to 0. Yeah. So S4 is what we're trying to find out. So minus 3 times S3 is nothing but minus 27 plus 2S2, 2 times S2. S2 we already found out, they already gave it as 5 actually, plus 12 times S1. 12S1 is nothing but 3 minus 8 is equal to 0. So S4, so that's plus 3 into 27, that's 81. 81 plus 10 plus 36 minus 8 is equal to 0. So that's S4 plus 91 plus, you can do this with a calculator, just 91 plus 28. That's S4 plus 119 is equal to 0. So S4 is just equal to minus 119. Which I should get my calculators here. Yeah. So we move on to the next question. So the lines L1 and L2 have equations minus 2, minus 3, minus 5, and minus 4, 3, 5. So minus 2, minus 3, minus 5, and minus 4, 3, 5 lambda. And 2 minus 2, 3 plus mu into 2 minus 3, 1. So find the shortest distance between L1 and L2. So the formula for this one is just A2 minus A1 into cross product of B1 times B2, dot divided by B1 dot B2 magnitude. Okay. So let's find out a2 minus a1. So a2 and a1 over here stand for the fixed points on the line. So a2 minus a1 is just going to be 2 minus 2, 3 minus minus 2 minus 3 minus 5. It's 4, 1, and okay, it's 8. Okay, let's find out b1 times b2. So b1 and b2 stand for the direction vectors. It's these two. So it's going to be ijk of minus 4, 3, 5, 2, minus 3, 1. So you can do this using calculator, or you can do this like using arithmetic. So it's just going to be 3 times 1 minus 15. So that's 18. And minus 4 times 1 minus 4 minus 10. Just wait, minus 4 times 1. Yeah, so that's minus 10. Oh, sorry, my bad. I'll just do a calculator. Minus 4 times 1 minus 5 times 2, which is minus 14. So minus of minus 14. And k. So minus 4 times minus 3, which is 12 minus 6, which is just 6. So this whole thing is just 18, 14, 6. And since we really only need the direction and the magnitude is not important, we can just cancel out all the common factors. Just divide it by 2. So we get 9, 7, and 3. Okay. It's not actually equal to it's. Okay. So yeah. And the magnitude of this is just going to be square root of 9 square plus 7 square plus 3 square. So let's plug this all in the formula. So we got, yeah, so 1 by square root of 9 square plus 3 square plus 7 square into a2 minus a1 is just 418 dot 973. That's going to be 4 times 9 plus 7 times 1 plus 8 times 3, 24, divided by square root of 9 square plus 3 square plus 7 square. I'll just do that. 4 times 9 plus 7 plus 24. That's 67. 67 divided by square root of 9 square 9 square plus 3 square plus 7 square. It's root 139. So this is the answer. Okay, let's move on. Okay. The plane pi contains L1 and the point with position vector minus 1, minus 3, minus 4. So there's a plane here. Okay, so we got a plane something like this. And there's the point minus 1, minus 1, minus 3, minus 4. And there's also a line over here. Okay, it passes through the plane. It's contains the plane contains it. So find an equation of the plane, giving our answer in the form ax plus by plus cz is equal to d. So to find the Cartesian equation of the plane, what we need is just two direction vectors on the plane, and and one point on the plane. So the reason why we need two direction vectors is to form the normal vector of a plane. So since it contains L1, it also contains the line of L1, the point of L1, which is minus 2, minus 3, and minus 5. So there's another point, minus 2, minus 3, and minus 5 here. So we can form another line using this, right? And using these two, we can find the normal vector. So let's first form this line, the other line. It's minus 2, minus 3, minus 5, minus 1, minus 3, minus 4. It's just minus 2 plus 1, minus 3 plus 3, and minus 5 plus 4, which is minus 1, 0. It's minus 1. And again, since direction is the only important thing, we can just get rid of these minuses. We'll make it a little easier. So 1, 0, 1. Okay. So now we also have the direction vector of the L1, which is minus 4, 3, 5. So we can find the normal vector. So normal vector is just going to be I, j, k, 1, 0, 1, and minus 4, 3, 5. Minus 4, 3, 5. So 0 times 5 minus 1 times 3, that's minus 3. J, 1 times 5 plus 4, it's 9. And 1 times 3 is just 3. And since we can cancel out all the 3's, it's just minus 1, 3, 1. So if we got this minus sign, so that's minus 3 times minus 9 times 3. Okay. So now that we found the normal vector, so we can just write minus x minus 3y plus z is equal to this thing dot product of this. So minus 1 minus 3 1 dot product minus 1 minus 3 minus 4. So that's going to be 1 plus 9 minus 4, so it's 6. Or we can say x plus 3y minus z is equal to minus 6. Okay, let k be a constant. The matrices A, B, C are given by A is equal to 1k, 3. Okay, it's given that A is singular. So show that CAB is equal to this matrix. So if A is singular, that means that its determinant is equal to 0. So let's find out K first, since it's unknown. So determinant of A is going to be 1 times 5 minus 3 times 2 minus K times 2 times 5 minus 3 times 3 plus 3 times 2 times 2 minus 1 times 3. That's just going to be 1 into 5 minus 6, which is minus 1, minus k into 1 plus 3 into 2 times 2 minus 3, that's 1. So that's minus 1 minus k plus 3. And just remember that this is supposed to be equal to 0. So minus 1 plus 3 is equal to k. So k is just equal to 2. Okay. So that's the first thing. So k is equal to 2. Actually, k is equal to 2. So now let's just do the matrix multiplication. So first let's find out AB. Yeah. So let's AB. We always go from right to left. So we get 1, 1, 2, 3, 2, 1, 3, 3, 2, 5 times 0 minus 2 minus 1, 3, 0, 0. So this becomes because you should know matrix multiplication if you're taking further maths. It's rather complicated to show on screen, but it's basically multiply each row by the corresponding column elements of the other matrix. So 1 times 0 plus 2 times minus 1 plus 3 times 0, which we get as 1 times 0 plus 2 times minus 1 plus 3 times 0, which is minus 2 for the top left element. And then the same thing for the other. So 1 times minus 2 plus 2 times 3 plus 3 times 0. Okay, so we got 4 for the top right. And similarly, just continue it out for all the remaining cells, and you get minus 1, minus 1, minus 2, and 0. Okay. So now let's find C times this one. So C is just going to be minus 2, minus 1, 1, 1, 1, 3. So times minus 2, 4, minus 1, minus 1, minus 2, 0. So you can note that we can actually just cut out basically the rightmost and the bottommost to form a 2 by 2 matrix, but let's just do it directly. So minus 2 times minus 2 plus minus 1 times minus 1 plus 1 times minus 2. That's going to be minus 2 times minus 2 plus minus 1 times minus 1 plus 1 times minus 2. Yeah, that's 3 on the top left. And similarly, just continue it out, and you're definitely gonna get the thing which they gave, which is 3 minus 7 minus 9 and 3. Okay, find the equation of the invariant lines for the origin of the transformation in the xy plane represented by CAB. So invariant line basically means that the points on this line stay on the same line even after the transformation. Yeah. So you got 3 minus 7 minus 9 and 3. So times xy is equal to capital X, capital Y, another point in the same line. And since y is nothing but mx, we can just replace it with mx. Yeah. Okay. So let's do the matrix times vector multiplication. So this is going to be 3x minus 7mx is equal to capital X, and minus 9x plus 3mx is equal to mx. And substitute this x here. So minus 9x plus 3mx is equal to m times 3x minus 7mx. Cancel out all the x's. So minus 9 plus 3m is equal to 3m minus 7m square. 3m can cancel. So 7m square is equal to 9. M square is equal to 9 by 7. M is going to be equal to plus minus 3 by root 7. So y is equal to 3 by root 7x. That's a 7. And minus 3 by root 7x. Okay. Yeah. The matrices D, E, F represent geometrical transformations in the xy plane. So D represents an enlargement, center origin. So that means that the unit vector I hat and j hat get enlarged by scale factor 0. So that's k0, 0, k. E represents a stretch parallel to the axis, which means that the unit vector I hat is just being stretched. So that's it goes to k0, and the unit vector j stays the same. By the way, you should know what this matrix means on the geometric plane. So f represents a reflection on the line y is equal to x, which means that I hat goes to the position of j and j goes to the position of I. So that's 0, 1, 1, 0. Okay. So CAB is equal to D minus 9EF. So CAB we already got as 3 minus 7 minus 9, 3. 3 minus 7 minus 9, 3. So this is equal to D. D is K0, 0, K minus, just give me a second. By the way, we shouldn't use the same letter for this enlargement when we don't know what it is. So you can use something else. K M M0, 0, 1 times 0, 1, 1, 0. So let's find out. To first complete the matrix multiplication on the right, which is going to be m times 0 plus 0 times 1, which is 0. Okay, m times 1 plus m times 1 plus 0 just is going to be m. Okay, m times 0 plus 0 times 1, that's going to be it's going to 0 b. By the way, this is 9. Hold on, m times 0 plus, that's going to be 0 again. What is it? Oh, sorry, no, it's going to be 1. And 1 times 0, that's going to be 0. So This is going to be k00k minus 9m, sorry, 0 9m 90. So we're going to get k 0 minus 9m is going to be minus 9m, 0 minus 9 is going to be minus 9, and k minus 0 is going to be k. So upon comparison, it becomes obvious that k is equal to 3, and minus 7 is going to be equal to minus 9m. So m is just nothing but 7 by 9, right? So using this, just substitute it back into all of this. So we got 3003. Okay, m0 is going to be 7 by 9001, and this stays as it is 0110. So these are the answers. Find D, E, F. Do we have to find? Okay, so let's move to the next question. Show that the curve with Cartesian equation x minus 1 by 2 square plus x y square is equal to 1 by 4 has polar equation r is equal to cos theta. So we're gonna have so remember the golden equation. So x is equal to r cos theta and y is equal to r sine theta. Okay, and x square plus y square is equal to r square as well. Okay, so let's do this. So substitute, or before we do that, we can actually just directly expand it. So x square plus 1 by 4 minus x, which is just a 2 into x into 1 by 2, when you expand the brackets, plus y square is equal to 1 by 4. So 1 by 4 and this 1 by 4 cancels. We get x square plus y square is equal to x. Bring the x on the other side. Okay, so x square plus y square is equal to x. So, and remember this is just x square plus y square is just r square, and x is going to be r cos theta. So r is just going to be cos theta. Okay. The curves C1 and C2 have polar equations r is equal to cos theta and r is equal to sin 2 theta, respectively, where theta is between 0 and pi by 2. The curves C1 and C2 intersect at the pole and at another point P. Find the polar coordinates of P. By the way, do we need to sketch this curve? Okay. Wait. Find the polar coordinates of the point P. So let's find the intersection. So cos theta is equal to sin 2 theta. So we can say cos theta is equal to, using the formula and mf9 to make it 2 sin theta cos theta. So either cos theta is equal to 0 or, okay, so we can do this. So just cancel out the cos theta. So we get 1 is equal to 2 sin theta. So sin theta is just 1 by 2. So theta is going to be sine inverse of 1 by 2, just putting it in radians. So sine inverse of 1 by 2 is pi by 6. And when you put this back, so find out r is equal to cos theta. So putting cos of pi by 6, we get root 3 by 2. Yeah. So the coordinates will be root 3 by 2 pi by 6. So this is the answer. In a single diagram, sketch C1 and C2, clearly identifying each curve and mark the point P. So you can use the table function on your calculator. Just plug in a bunch of values of pi, ranging from pi by 6 to pi by 3, pi by 8, and all of those, and find out the respective r. But there's another hint you can just get. So they gave x squared plus y squared is equal to x, and you should know that this is the graph of a circle. So this is actually just going to be a circle like this. And since they're only asking us from theta is equal to 0 to pi by 2, it's going to be a semicircle. I'm going to draw that properly. So this is the C1, and C2 is going to look something like this. Okay, so yeah, and mark the point P. So this is the point P of intersections, right? Yeah, this is P. So let's move on to the next question. The region R is enclosed by C1 and C2 and includes the line OB. Find an exact form the area of R. So this is the line OP. This is the OP. So they're asking us to find out this region, okay, enclosed by the both of them. So if you notice, it's actually just going to be the integral from 0 to pi by 6 of C2 d theta plus the integral from pi by 6 to pi by 2, which is this is the line, right? So we're calculating in two parts, one before the line and one after the line, right? So the before the line part is going to be the integral from 0 to pi by 6 of C2, and after the line will be from pi by 6 to pi by 2 of C1. Okay, so let's just find that out. So C2, to take the polar integrate, we have to take half r square. So 0 to pi by 6 of half r square. What is r of d2? It's sine 2 theta. So it become sine square 2 theta d theta plus integral of pi by 6 to pi by 2 of c1. Again, don't forget the half cos square theta d theta. Okay, so just checking MF19 for the, because those are difficult to integrate. So first thing we get is that cos 2 theta, the formula is going to be 1 minus 2 sine square theta and 2 cos square theta minus 1. Okay, so let's find out this thing in terms of only multiples of cos. Let's just rearrange and find out what cos square theta and sine square theta are. So cos square theta is going to be equal to cos 2 theta plus 1 by 2, and sine square theta is going to be cos 2 theta minus 1, 1 minus cos 2 theta actually. Okay, so here we've got sine square 2 theta, which means after plugging in 2 theta in place of theta here we get 1 by 2 integral from 0 to pi by 6 of 1 minus cos 4 theta by 2 d theta plus half integral from pi by 6 to pi by 2 of cos square theta. We just found cos 2 theta by plus 1 by 2. Okay, d theta. Okay, I'm gonna factor out this 1 by 2. So that's 1 by, actually I might as well just do it here. Okay, so keep that 1 by 2. So 1 by 2 into, I'm not gonna add the integration limits right now, so that's 1 by 2 minus cos 4 theta by 2 d theta plus integral of cos 2 theta by 2 plus 1 by 2 d theta. Okay, so just evaluate this. So it's going to be theta by 2 minus, so integration of minus cos will be minus sine, so minus sine 4 theta and divide by the coefficient of theta, which is going to be 8. So this is from what, the bounds of this integration is from 0 to pi by 6, okay, plus half of integration of this one will be integral of cos, again will be sine, so sine of 2 theta divided by 4 plus theta by 2 from 0 to sorry, from pi by 2 to pi by 6 to pi by 2. So just evaluating this, what we get is, oh, you can actually simplify this further, but okay, I'll do this directly. It's gonna be, okay, but when you evaluate fully, you're gonna get this uh, pi minus 3 by 4 root 3 divided by 8. 3 root 3 by 4, yeah. So let's move on to the final question. So the curve C has equation y is equal to f of x, where f of x is equal to x squared plus 2 by x squared minus x minus 2 divided by. So find the equation of asymptotes of C. So first thing we notice is that coefficient, the powers of x is the same, the degree of the numerator and denominator is the same. So that means there will be a horizontal asymptote, which is just going to be the coefficient of this one divided by the coefficient of this one, bottom one. So that's just going to be 1, because 1 divided by 1 is just 1. So, sorry, y is equal to 1. That's a horizontal asymptote. And equate the denominator to be 0. So x1 minus x minus 2 is 0. So just solve it. Uh, you get x is equal to minus 1 and 2. So yeah, these are the three asymptotes. So y is equal to 1, x is equal to 2, and x is equal to minus 1. Okay, find the coordinates of any stationary points in C, giving our answer correct to one decimal place. So we just do the quotient rule. So first let's find dy by dx. And first we know that for a stationary point, the dy by dx should be equal to 0. So dy by dx is going to be, using the quotient rule, x squared minus x minus 2 into the derivative of the numerator, which is 2x plus just 2x, minus numerator, which is x squared plus 2 into derivative of the denominator, which is 2x minus 1 here. So divided by x squared minus x minus 2 whole square. So this should be equal to 0. So bring this to this side and it just dissolves in the 0. So we don't need to do that. So let's just focus on this part. So we get x cube minus 2x square minus 4x. Oh, it's 2x. Okay, so this part just becomes 2x cube minus 2x square minus 4x. 2x cube minus 2x square. Yeah. Minus 2x cube plus 4x square sorry 4x, yeah, 4x minus x square minus 2. It becomes 2x cube minus 2x square minus 4x minus 2x cube minus 2x cube minus plus x square minus 4x plus 2 is equal to 0. So 2x cube and 2x cube cancel. Minus 2x square plus x square becomes minus x square. Minus 4x becomes minus 8x. And go to plus 2. Okay. So x square plus 8x minus 2 is equal to 0. So let's just find out what the solutions are for this. So x is equal to minus b minus 8 plus minus square root of b square minus 4 is 6. So 64 minus plus 8 actually divided by 2a. Just 2 square root of, so minus 8 plus square root of, one of these will be 0.2, other one will be minus 8.2. And substituting these back in the original function f of x, take f of 0.2 and f of minus 8.2, we get y is equal to, for 0.2 we get minus 0.9, and for minus 8.2 we get 0.9. Yeah. Okay. So these are the 2 points. So 0.2 and minus 0.9, minus 8.2 and 0.9. Okay, 0.2 and yeah. Okay. So this is the answer. So sketch C stating the coordinates of any intersections with axes. So we got this. So we know the asymptotes y is equal to 1. So somewhere over here. It's not straight. So this is the asymptote y is equal to 1. And we got x is equal to 2 and x is equal to minus 1. It's let's also just draw the stationary points real quick. So 0.2 and minus 0.9. So 0.2 somewhere here, minus 0.9. So that's one stationary point. Other one will be minus 8.2 minus 0.9. Minus 8.2 and 0.9. Okay. So it's going to be somewhere over here. It's actually going to be much further on the left, but I'm going to have to squish it to fit it. Okay. So just looking, and you should have the intuition to solve this, so you can tell that this is going to be this. This is the shape of the graph here. And let's also find the intersection with the y-axis by plugging in x is equal to 0. So we have 2 by minus 2, minus 1. So this is going to be it's going to be something like this. And then this is going to be something like this. Yeah. Sketch a curve with the equation y is equal to 1 by f of x. Okay. So basically what you need to know is that all the asymptotes, where all the vertical asymptotes become intersections with the axes. So at x is equal to minus 1, there will be an intersection. So again minus 1. And at 2 also. So now 1 by f of x will just become x square minus x minus 2 divided by x square plus 2. X square minus x minus 2 divided by x square plus 2. So there will be an intersection of the axis in the same place. I can just try uh, put x is equal to 0, and you see that the vertical intercept will just be minus 1 again. Okay. And the vertical asymptote stays the same. 1 by 1. It's just going to be the same. Okay. Now the important part to note is that the this stationary points, right, are there, right? They will get divided, but their reciprocal has to be taken too. So here's the one stationary point we need to focus on. So this is the one minus 8.2 and 0.9. So it becomes 1 divided by 0.9, which is going to be something like 1.1. So it's actually something above the axis here. Okay. So now we can just look and check. It's going to be something like this. Okay. So yeah. Find the set of values for which f of x is greater than 1 by f of x. Just read it like this. So if you superimpose the graphs on each other, which parts will the graph of f of x have like a higher value than 1 by f of x? So first thing we have to notice is that, oh yeah, we forgot to put the stationary point for this also. So this is the stationary point 0.2 and minus 0.9. Okay, so this stationary point becomes 1 by minus 0.9, which actually becomes minus 1.1. So it's actually going to go a little below. So this one. Okay, so now notice this. So comparing these two graphs, this graph went something like this, right? Previous graph. So it was definitely greater for over that between this region, this region. So let's find out what this region was. Uh, so 1 by f of x is going to be x square minus x minus 2 divided by x square plus 2. So just find out the intersection points right now. So x square plus 2 divided by x square minus x minus 2. So x square minus x minus 2 whole square is going to be equal to x square plus 2 whole square. Taking the roots on both sides, we get x square minus x minus 2 is equal to x square plus 2. And don't forget the plus minus, you have to form another equation also. So x square minus x minus 2 is equal to minus x square minus 2. So here x square and x square cancel. So we have minus x minus 2 is equal to 2. Minus x is equal to 4. X is equal to minus 4. So that's going to be one intersection. So it's presumably somewhere over here, this point. Was that graph came something like this, right? So there's going to be an intersection here. Actually, it comes at the same vertical point, so something like this. We just erase that one. Yeah, 2x squared is equal to x, so 2x is equal to 1, so x is equal to 1 by 2. And x is also going to be equal to 0 because that's also a solution. So this is going to be the point 0 and this is going to be the point 1 by 2. So f of x is going to be greater for between these two values, 0 and 1 by 2. It's also going to be greater for this one. If you notice, there was actually a horizontal asymptote here. So between these 2 points, between minus 1 and minus 4, f of x is actually greater. So yeah. And also, if you notice, for this horizontal asymptote, f of x was over here, and it was definitely greater than, so this at the horizontal asymptote, x is equal to 2. So x is greater than 2. So I'd recommend you to have a plot of both these graphs on Desmos to visualize how they come about.
Okay, thank you everyone for listening to the video, and don't forget to subscribe to stay tuned for more episodes coming the way. Goodbye and see you in the next video.